Hi class, for this example, let's take a look at this data set, and they're asking us to do a couple of calculations. So they want us to do, well, we're going to treat it as a sample, and we're going to do the standard deviation, the variance, and then provide an estimate for the standard deviation. So your first step, and I don't want you to do this example like example 2. I want you to do the shortcuts, but on any shortcut, this is what I need you to do. So please enter the data set, and you can put it in any of the list. In this case, I have it as L1, and let me double check that there's no errors in the entering the data set. It looks good. And then the first step is I need you to run me a one variable stats, and we're going to run it under L1. Oops. And then for the first one, well, this is just the standard deviation. So technically this is going to be S, and this is equal to, I need to see it as the variable followed by the formula. So this is the sum of x minus x bar squared divided by n minus 1. And then somewhere tell me that you're using the shortcut, and you can just say one variable stats. And in this case, I'll know that you're using the one variable statistics. So therefore, I won't be expecting that you're doing what we did on the previous problem. Now, this is only for raw data. We're going to do in the labs group data. In group data, we definitely need technology, and it becomes really messy to actually evaluate. So this is what I have. Running my one variable stats on this data set, I'm obtaining the following. And in this case, well, we have a mean of 78.125. Since this is a sample, your standard deviation is this one. So 16 point, so this is going to be approximately, oops, for this one, approximately, I'm obtaining 16.6256. So 56, and that is rounding to a total of 4 decimal places. 16 point, I'm looking at 6256. I believe that's what we obtained, 16.6256. Now, the actual problem doesn't, or the one variable stats will not give you a value for the variance. You're going to have to compute this one manually. So I still need to see the formula. So in this case, this is s squared. Whoops, I forgot the square root here. And this is the sum of x minus x bar squared divided by n minus 1. So you would have to do 16.6256 and technically square this value. So you would have to do it separately. This would be 16.6256 and then squared. That's going to be your answer. So 276, this is approximately 276.4106. So 0.4106, I'm rounding to 4 decimal. Make sure you follow directions on the homework. They're very picky on how exactly they want it. So 4106, that would be rounding to 4 decimal places. So that is our main calculation for the standard deviation and the variance. Now, for all of these, I'm going to need the actual variable that you're using, the formula associated with it. So in this case, I'm actually missing, this is supposed to be a 2 there. And then your output from the one variable stats. It's not needed that for raw data, you do what we did on example 2. It would take forever to do the calculation. So we're using technology for that part. Now, it gets a little bit confusing depending on what they're asking. So let me go back to the formulas. And the main difference is, do you have a population? In that case, that's the value for the standard deviation. if you have a sample that's S, and they may ask you to do an estimate. Now, this estimate you only use if they're asking for the estimate. If not, you go directly to the standard deviation. So in this case, they want an estimate. So you would just say that the estimate of S and we're just going to say that the standard deviation is approximately the range divided by 4. So from the one variable stats, in case you were to have like a very large data set, it already gives you these values. This is just to ensure that you don't accidentally pick another value that's not there. So your maximum value happens to be the 95. So 95 minus the min value, which is 60, divided by 4. That would be the formula. So 95 minus the, 55 is the min. Divided by 4, and as you're punching it in into the calculator, you're going to need parentheses there. So please evaluate. We'll compare values. In this case, I'm obtaining the values of 10. Okay, so that is it for example 3. And once again, you only use this estimate formula if they're asking you to estimate it. If not, you go directly to the one variable stats and obtain, well, the proper row. So let's take a look at example 3, and we're going to use the same format. Please take a second and punch it in into a data set. In this case, I already have it. Let me double check. Under L2, so 12. And then run me a one variable stats, but make sure that you match with the where you have it. So on this particular problem, I have it under L2. Okay, so they only want the standard deviation and the variance, but we're treating this as a population. So remember that the formula, it's very similar, but you're going to be dividing by technically n, not n minus 1. So on this example, I'm just going to say that the values of sigma, so sigma for this one is equal to the square root of the sum of x minus mu squared divided by the values of n. Now, it's sufficient to just retrieve the value. So let me just double check that this is in fact from L2. And the value of the standard deviation, since we're treating it now as a population, that's this little sigma here. So this is going to be equivalent to 13.59 and then 47. So I'm using 4 decimal places. Please be careful because the software, for some problems on your homework assignments, it's only asking for 2. And then for the variance, well, in this case, this is going to be sigma squared. You're just going to do the sum of x minus mu squared divided by n, or technically the 13.5947 squared, and evaluate that, and we'll compare answers. I'm getting that this one gives us 184.81 the 9 to 4 decimal places as well. So all I really need to see is the same as we did before, the actual variable, the formula associated, and then the calculator. I do need you to tell me somewhere that you're doing a one variable stat. That's just to make sure that I understand that the calculation that you're obtaining is this one. And I won't give you very large data sets, because if you accidentally miss one of the values or there's a typo, well, your main calculations are going to be way off. So that's actually it. Once again, for all the calculations on 3.2 standard deviation and variance, for raw data, I just need the variable, formula, and then your output, and then technically where you obtained it.